Hello and welcome to this presentation called Illustrating JavaScript Dependency Hell, the Left-Pad Thought Experiment. My name is Marc Dumais. I have been working at Ericsson for 22 years as a software developer. The last decade or so, I have worked in things related to FOSS, mostly in the development tool area, and most particularly in IDEs. I am part of the original team that created Eclipse Theia, the IDE framework for the desktop and the cloud. I am also a co-lead on that project, and I am the internal lead in the Ericsson team that contributes daily to Theia. There's my email address if you have any questions. So today, we will go through a few things before we get to the thought experiment. So we will go a little bit into what LeftPad is. Then we will need a little bit of background about the NPM registry and dependencies of NPM packages to finally get to the more practical aspect, our little LeftPad thought experiment. So what is LeftPad? Well, it is, you see it pasted on the side here. It is just a tiny little JavaScript script of 11 lines that became infamous a little while ago in 2016 when it was unpublished from the NPM registry, which, by the way, should not be possible anymore. So at least a disaster like this could not happen again, fingers crossed. So when it was unpublished, it broke a bunch of very important applications and services that relied on it. Most of them did not rely directly on LeftPad, but had it deep in their dependency tree. So you can see here a few of the headlines that followed this incident. Yeah, it broke, maybe saying it broke the internet is a bit hyperbolic, but it's not that far from it. It broke a bunch of things. So how can 11-line, simple line of JavaScript break the internet? Well, to be able to understand that, we'll need to go a little bit into background information. First part is, what is the NPM registry? So the first thing to know about it is that it's huge. It is the biggest software registry or repository in the world. It dwarfs the other big ones that we usually think about, like Maven Central or RubyGems and so on. So by itself, it is bigger than all of the other one illustrated here put together. And its rate of growth is also much higher than the competitors. So it gets bigger, that difference gets more wide as we go rather than the reverse. So the public instance of NPM is available at this URL here. A few things to know about NPM. The barrier of entry to publish something there is really, really low. So anyone can publish something there in a few minutes, which means that not necessarily all the content there is of good quality. Maybe even a minority of the content is of good quality, but there's lots to choose from. So you can probably find something interesting, but well, there's a lot of noise in the registry. NPM stands also for, well, it stands for Node Package Manager, but it is also the name of the client that comes with Node.js, one of the potential clients you could use to build your applications. So NPM, it contains packages or libraries for JavaScript development. JavaScript is probably the most popular language right now, at least according to the Stack Overflow survey, and it has been for several years. One of the things that makes JavaScript a bit special is that it has no standard library like you would have in most languages. So instead, developers have to rely on whatever is on NPM. Yeah, other languages like C, for example, you will have the C standard library that you can rely on, but not so with the case of JavaScript. So you have no choice. Either you build it yourself or you use something from NPM. Maybe stemming from that, I'm not sure, but there is a strong cultural preference in the NPM domain to reuse packages instead of reinventing the wheel. And it sometimes goes to absurds, like including a package instead of rewriting a couple of lines of code. But it is a fact that it happens. So the consequence of that is that on average, a random package will have more dependencies than you would have in other languages. And if you look at the dependency tree, it will be deeper and more furnished. Here's a funny little meme about NPM. Here, all you need to know is that node modules is the folder where the NPM dependencies are saved when you build your application. So basically it's saying that node module will be bigger and heavier than a black hole, which is maybe exaggerated a bit, but there is some truth to that. So what are the consequences of this? Well, you will use more disk space for sure. The node module folder will be heavy. You will have probably exponentially more numerous dependencies to handle, not just when you program, but for like administrative tasks. For example, when you make sure that license are okay or that all the packages don't have vulnerabilities. The dependencies not only are more numerous than in other languages, but they have a tendency to change quickly. And it can be a little bit difficult if a deep dependency that is not one of your first level dependency, for example, needs changing. It has a vulnerability or something like that. There's no easy way necessarily to address something like that. And generally, more dependencies means more chances for something to misalign or to go wrong. So more upkeep just to keep the application running. So this is all versus more traditional ecosystems, languages like C or Java, for example. So they will have these problems, but not at the same scale. All right, now that we know a little bit about NPM and how it works, let's look at from the perspective of a single package. How does a package define its own dependencies? Well, it's easy. Each package will have a file called package.json, a manifest that will list these dependencies. So you will have basic information like the name and the version of the package. And in the dependencies section, you will have all the runtime dependencies that are needed when you run the package. And in another field called dev dependency, you will have the dependencies that are necessary to build and test development time dependencies, basically. And from that information, the NPM client can go and fetch everything that is needed for a given use case. So here we have dev dependencies. Okay, and let me introduce quickly a tool that we will be using today to visualize things a little bit and experiment. It's called NPM Graph. It is open source. The link to the GitHub is here. License is MIT. And there is a hosted version that you can use to play with the vanilla version or code of NPM Graph that is listed here. So we will be using this. And as a quick example, let's use the public NPM graph to look at Theia Core. So Theia is the project I work on, the IDE framework, and Core is the core extension, or that's really the framework, the core of the framework that is in there. All right. So I opened it in the NPM graph right now. You can see it has 299 dependencies that were pulled. That is out of roughly 60 first level dependencies. So the rest will be just dependencies of dependencies, like deeper dependencies. If we look quickly, we can see the graph starts here with Theia Core, and every orange arrow points towards a first level dependency of Theia Core. Everything else are the dependencies of dependencies. So yeah, NPM Graph is a nifty little tool. You can play around with it and really go and see what depends on what. That's pretty interesting. I wanted to show you something quickly. If we go back in the list here, some of them have a number besides. It means that there's more than one version of that given package. So debug has 3 versions. We see one here, 269, and a couple more here, 081 and 327. So these versions are in principle not compatible with one another because they vary, the major version varies. So in this case, they happen to be the same package, but you'll need the 3 versions for things to work correctly. Okay, and then we can get to our little thought experiment. We have a bit of background information now. So let's look at LeftPad dependency-wise. So LeftPad is a very modest package. This is why I chose it as an illustration, that and the fact that it's now infamous. So it has 0 runtime dependencies. So at runtime, it is self-contained. It's 11 lines of JavaScript code, and it needs nothing else at runtime. At development time, it has 3 dev dependencies that we see listed here. And I'll take the time to mention that the version can be a single version like we have here for fast check. It can be a version range like for benchmark. This means at least 2.1.0, but as long as it remains compatible, so less than 3 dot something. And for tape, it is just like, give me whatever. That's basically what it means, the star. So if you want to develop LeftPad, you have these 3 dev dependencies. Is that all? Well, not really, because these development dependencies will have runtime dependencies of their own. So little exercise, how much do you think, how many packages in all will be required in this case? So let's use NPM Graph to figure this out. So LeftPad, by default, it shows only the production dependencies. So we have only LeftPad, but let's enable dev dependencies. And there we go. So bird's eye view. At the root, we have LeftPad. And then we have the 3 dev dependency that we saw, benchmark, fast check, and tape. Everything else you see are the runtime dependency, recursive runtime dependency of these 3 things. And maybe surprisingly or not, you end up with over 100 packages needed just to build and test LeftPad out of the 3 dev dependencies and 0 production dependencies that this package has. So yeah, quite maybe more than most people unfamiliar with the JavaScript ecosystem would think. But yeah, about 100 packages are needed just to be able to run the test and package this LeftPad thing. So now forward to the slightly more interesting part of this, so the thought experiment with LeftPad. So let's say that you are a little bit paranoid and you don't trust necessarily the content on NPM. You don't trust that it is what it claims to be. A given package will point to a Git repository and it will claim that this version of the package corresponds to that version of the code in the repository. So let's say you do not trust that and you would like to rebuild the package yourself. So that's totally doable. We saw that it takes roughly 100 dependencies to do that. But let's say you're slightly more paranoid than that, and you also don't trust the dev dependencies. What could you do? Well, one possibility would be to try to rebuild the dev dependencies as well. But then do you trust the dev dependencies of dev dependencies? Maybe not. So let's say you do not. It would mean that you would need to rebuild the whole dependency tree, including the dev dependencies of everything. So how many would that be? would it be completely crazy to do? It's not something that is done normally for sure. Would it be like maybe 100 package needed? Probably more than that. We already have 100 just for left pad. 1,000, 100,000? Well, this is, let's find out. This problem is very similar to just letting NPM graph recurs through the dev dependencies, which is not doing by default. So we will be reusing NPM graph for this, just tweaking the code a little bit to permit us to get an answer to this problem and see if it might be maybe not so crazy after all, or maybe it is. So we will use a slightly modified NPM graph. I have put it on my GitHub fork here, and we have 2 branches. So my first experiment ended up not working so well. Basically, it would freeze my browser for a long while, and it will not finish. So I will not, well, I will show you why without going into too much detail. Here is the dependency graph I obtained. It is quite big, but mostly relations, not necessarily number of packages. To be able to obtain this, I limited the number of packages to 100 in the whole graph, and it took some minutes to crunch. So if we had 1,000, it would never finish, probably. So I know it's really small, you cannot see the details, but the idea is that the number of relations seem to increase exponentially, and it makes it unpractical to compute this with many dependencies. So unfortunately, we will need to disable the graph to be able to get to the numbers that we want. So this is why. In my second branch, I disabled the graph, and I was able to get some more meaningful results. So we can go and have maybe a quick look at that pull request. Maybe just the highlights that might be interesting here. So I made it so that I can go any depth I want. This is the variable. So basically, I run it multiple times, increasing the depth level so that we get more and more, deeper and deeper into the dependency graph, and hopefully closer to an answer as we go. So it has the ability to bail out when it reaches a certain level. And I have, here basically disable what did not permit it before to recurse into anything except dependencies, because for this thought experiment, we want to also recurse in the dev dependencies. So I added some printouts so we can have an idea what is going on. And I did not feel good about hammering the NPM server, so I am using a local registry called Verdaccio. So instead of connecting to the real NPM server, it will connect to my local registry, local host at this port. And that is about it. So let's run it quickly. So when we start, I limit it to 3 levels of depth, so that makes it more manageable. I will not show you the deeper levels because it takes a little while to run, but at least I can show you, the principle. So I have built and I am running NPM Graph locally, my modified version. So I can just access it now, localhost 1234. Left pad. I will open the DevTools. Oh, let's get the DevTools. So it will not take too long anyway. So one of the modification I did here, also I added a bit of detail in the pane, I modified it a bit. So we see level, if we go 3 levels of depth, we're already up to 550 some dependencies. And that includes a bit over 100 that are the repeats, so same packages but different version asked. And in the second pane here, we can have a bit more detail about how many versions are required are requested per package. So we see there are a few that have several different version requested. And to give you an idea of how of the growth or how many more packages are found when we go just one level deeper. I'll do it here for 4 levels. So we were at 500 roughly for 3 level of depth. And that should just take a second. And you see we are now at almost 3,000, including about 1,000 repeat packages of different versions. So you can see that there is some exponential effect at play here. And what I did is offline, I ran this and I saw that it at some point it levels off. So a little caveat, I just want to mention that NPM graph is not meant to do this. So, and it's very possible I introduced bugs by modifying it. So let's just take it as a order of magnitude rather than a very precise result. As well, LeftPad is pretty old, so some of the dependencies were not found at all. They don't exist on NPM anymore. So really, we are. It's only to give us an idea, basically. So without waiting further, let's go see what it looks like. So we did together 3 and I guess 4 levels. I did not record 4 here. You can see when we get to around 10, then we're past 30,000. And at around 50, it levels off at a bit past 60,000 dependencies. So that is total. Out of these 63,000, about 22,000 are just new or repeat version of the same packages. So roughly 1/3 of these packages are repeat. So when we actually build something, the NPM client is pretty smart about filtering out versions that are not needed or finding a version that will satisfy multiple version range from different packages. So the real answer will probably be somewhere between the 63,000 and 22,000, somewhere in the middle, probably. So for sure, if we needed one version of everything, then it would be closer to 22,000. If we assume that each version is unique and is required for some reason, other version will not do, then we're more at the 60-something thousand. So this is quite many packages to build from scratch and put in a local registry. So I would say personally that it sounds a bit like a crazy idea to go down that road. But of course, it's not the only way to go. There's no need necessarily to rebuild all the dev dependencies from multiple levels. Maybe one level would be enough. Maybe you just trust the dev dependencies. In any case, doing them all seems like a lot of work. So I just scratched the surface here, but I put a couple of links. So these 2 articles are really interesting if you are concerned about NPM and how the dependencies work, the quality and the problem that having a lot of dependencies and deep dependency trees bring. And I have also a link to the LeftPad incident article that I add in the presentation. So I hope you learned something today, and it was kind of a light, like and fun presentation. Take a test drive of NPM Graph by yourself. Have fun with it. Try my forked version if you like, and let me know what you think. Thank you. Hello. So I'll go right ahead. We have one question so far. What originally got you interested in NPM dependencies issues? Um, well, Thea was my first project that had anything to do with NPM. So about 5 years ago, I guess I was exposed to the magnitude of the problem. But especially when we moved Thea to the Eclipse Foundation and the IP team started to help us to do the IP scrutiny, it became very, very clear that there were practical downsides to having so many dependencies. So that's what got me first interested, and I was the main uh, team member of the project to interface with the foundation for these things. Yeah, I was very aware. Given the potential challenges, is it worth to start something new using JavaScript and NPM? Yeah, I guess like everything in engineering, it's a trade-off. It will depend. NPM is an amazing library. There's amazing stuff in there, but you need to take into account the cost of using these amazing things. If you have the choice between two dependencies, maybe one will look a bit shinier, but it will have a deep dependency tree. The other one will be self-contained. So you can make maybe good choices up to a point to mitigate this NPM characteristic, but you have to expect that it would be more work to deal with these dependencies than in Java or C. So yeah, to do something like that, I think it was the only way, or it would have taken a huge team to do this from scratch in Java, for example. What about Deno? Will it solve some of the issue? I am sorry, I do not know what Deno is. So it sounds like this is all the questions. Oh, okay. Maybe we'll try to clarify the question. Is the NPM barrier of publishing packages too low? I guess it's a judgment call. I think it being low has led to a lot of stuff and probably some good stuff being on NPM. And yeah, changing it at this point, I'm not sure would be the solution. Um, so one of the two links I had in the at the end of the presentation goes into a lot of detail about how one might fix NPM, and I would suggest to read that article. All right. So I think there's no further question. We can wrap this up. So thanks a lot for your attention, and drop me an email if there's anything. Goodbye.